In this video, we're going to look at how to add and subtract rational expressions. So when I say rational, I just mean fractional expressions. So we're going to start with a numerical example so we can, remember how to add fractions. I know this seems weird, but how to add fractions. And then we're going to take it a step up and add fractions that have variables in them. Okay. So let's start with an example with just numbers. So in this example, we're going to have 2/3 plus 4/5 minus 2/15. And again, I'll take it up a notch later on. So in order to add and subtract something with different denominators, we have to get a common denominator. You may recall we need a common denominator. So our common denominator will be the lowest common multiple of our 3 or 5 and 15, the lowest common multiple. So when we look at multiples of 3 are 3, 6, 9, 12, 15. Multiples of, and so on. Multiples of 5, 5, 10, 15, 20, and so on. Multiples of 15, 15, 30, 45, and so on. So those are what multiples are, and we're looking for the lowest common one, which is, if you said 15, you are correct. So our lowest common multiple is 15. So everything is going to be over 15. All right. So here's the question. What do we have to multiply this 3 by in order to get to 15? And yes, that is correct. We have to multiply it by 5. Whatever we do to the bottom of this fraction, we have to do to the top of this fraction as well. So we've just created a way to figure out an equivalent fraction to 2/3. And that is by multiplying the top and the bottom by 5. So here we have a new fraction, 10 over 15. It's actually just another way of saying 2/3. Alright, so let's go through and do the same thing for the next two fractions. What do we have to multiply 5 by to get to 15? Yes, we have to multiply by 3. So we have to do the same to the top, and we get 12 over 15, which is the same as 4/5. And we already have this over 15, so we don't have to make any changes. It's just 2 over 15. At this point, now that we have everything over 15, we can just have everything over one nice, beautiful, big 15. And it's really 10 plus 12 minus 2. All I just did was rewrite these numbers together, 10 plus 12 minus 2. And that should give us what we are looking for, which is 20 over 15, which can simplify to 4 over 3. And so just to remember how to simplify, the 5 is a common factor, so we divide everything by 5. We have 4 when we get 4 when we divide that by 5. We get 3 when we divide that by 5. All right, great. Let's actually move on to something a little bit more challenging with variables. Okay, so we just worked with a numerical example because I wanted to show you that that is exactly what we'll be doing even when we're working with variables. So again, we're going to look for the lowest common multiple of our denominator. And so we have numbers and we have variables. So the lowest common multiple of our numerical part, we have 6, 2, and 8 for our numerical part of our denominator. The lowest common multiple is going to be 24 because that's the lowest number that when you multiply 6 and 2 and 8, that's the lowest number that they have in common as multiples. All right, so that is only a part of our new denominator, but I'll write that down so we have it down. Okay, but that's not everything. Now we have to look at each variable. So the lowest common multiple for our a's is a squared. So it cannot be a because a is not a multiple of a squared, but a squared is a multiple of a. And so that's the common multiple for our a's. So we can put that down. A squared, and a squared. That's the lowest common multiple for the a's. So what's the lowest common multiple for the b's? If you said b squared, you are correct. b squared, and b squared. So that is our lowest common multiple. A lot more complex than what we just did, but doable. All right. So now we're going to ask ourselves the same questions that we asked ourselves before. So that is, what do we have to multiply 6a squared by to get to 24a squared b squared? Well, 6 needs to be multiplied by 4 to get to 24. A squared doesn't need to be multiplied by anything because it's already a squared. And there is no b, so actually we need to multiply by b squared to get to our 24a squared b squared. So we're multiplying the bottom by 4b squared. And so we have to do the same thing to the top. Multiply by 4b squared. All right, let's look at the next one, the next fraction. What do we have to multiply 2ab by to get to 24a squared b squared? Well, 2 to get to 24, we have to multiply by 12. To get a to a squared, we have to multiply by a. And to get b to b squared, we have to multiply by b. So that multiplication will get us to our LCM, or lowest common multiple here. But whatever we do to the top, as you know, has to happen to the bottom, or vice versa, sorry. Whatever we do to the bottom has to happen to the top. Okay, cool. All right, and one last one. We have 8b squared here, and we need it to get to 24a squared b squared. And we can do this one a little faster because I think you're getting the hang of it. So this has to be multiplied by 3a squared. And that would get us to 24a squared b squared. And again, we need to do the same for the top. So 3a squared. Okay, now that we have that all set up, now we can fill in what we know how to fill in. So we have here 1 times 4b squared, and that gives us 4b squared. We have 1 times 12ab, and that gives us 12ab. And finally, we have 3 times 3a squared, and that gives us 9a squared. And our signs are the same, minus and plus. And so we are ready to move on to the next step. Our common denominator, 24a squared b squared, we can write it one time. We don't have to write it 3 times. And I'm just rewriting everything from the top. We have 4b squared minus 12ab plus 9a squared. Awesome. What do we do now? Well, anytime you want to simplify a rational expression, what's the first step? If you remember that the first step is factor, awesome job. Okay, so we need to see if we can factor this expression. So, looking at the expression, we are able to see that it is actually a perfect square trinomial. And if you don't remember what a perfect square trinomial is, you need to look back at the factoring notes or the factoring video. Okay, so that means that we have here 2b minus 3a, 2b minus 3a over 24a squared b squared. Now there's nothing in common here. We can't factor out a common factor, and that's okay. That means it's already almost basically in our simplest form. But since these two guys here, this guy here and this guy, are the same, we just have one more step and it will be in its simplest form. We have 2b minus 3a, oops, 1 second, there we go, minus 3a squared, because they're the same, over 24a squared b squared. And we're done.